10th students in our chemistry class, and as all of you know, analytical chemistry we are dealing with, and today we are going to end this chapter or complete this chapter, because the method to go through that chart, the reaction with NaOH and NH4OH, I have already told you, you have to recognize the color of the precipitates and drop by drop and then in excess. Now we have studied about NaOH, now we are going to study about NH4OH, that is ammonium hydroxide, drop by drop and in excess. So both these tables you have to memorize, because both will give you an idea how to detect the metallic ions. Suppose some are soluble in some are insoluble in excess of NaOH, so they are soluble in excess of NH4OH. They are insoluble in excess of NaOH, so they are soluble in excess of NH4OH. So likewise, you can, by comparing or by just pre-knowing the things, you will determine or you will be able to know what the metallic ion basically consists of, and the whole laboratory work depends on this table. And the third one is action of NaOH or the reagents over some metals and their oxides and hydroxides. And basically what we deal with the amphoteric ones. And what are the amphoterics? Oxides or hydroxides? You can say amphoteric oxides are those which show both the character, the acidic character and basic character. Means, what is the point to be taken care of? The point to be taken care of is that amphoteric oxide behaves as an acidic oxide, as an basic oxide. Means, when it will behave in an acidic oxide, it will react with base to give salt and water, and vice versa. When it will behave as a basic oxide, it will react with acid to give salt and water. So in the last table in your book also, that part is given. So that is to be memorized. How it will be helpful? It will helpful for some of the amphoteric oxides and like aluminum, like lead. So you can recognize by those pre-knowing, by those reactions or by those observations, yes, this may be the amphoteric oxide, so this may be that metallic ion, so this will be this metal in the unknown substance. So this is all about and I have just copied whatever was there in the book and I have copied it on the board. I will just go through it, and rest I hope that you have understood it. Again, I would like to remind that what does these reagents do? These reagents produce OH minus ions. If they are strong like NaOH, they will produce 100%. If they are NH4OH, weak alkali, it will produce to some extent. The ionization or the dissociation rate will be low. So these OH minus help to make the hydroxides, that is, make the precipitates which settle down. And we, by pre-knowing the color of those precipitates, we are able to determine that this is this metallic ion, so this is this metal. So just let's have a look and just go through it. So dear students, before you we have the chart, and it's well given in your book also. With the salt solution, we are adding ammonium hydroxide drop by drop, and then we are getting metal hydroxides, and salt formed in the solution, it's soluble one, and this is the first step. And after that, what we do, we add it in excess and observe what happens to the color, first thing, and whether it is soluble or insoluble. So this portion is to be crammed. It's very, very important, make in mind. Now calcium salts, it is given no precipitation occurs with addition by drop and even in excess. The reason is that calcium salts, which type of alkali is? It's a weak one. It's a weaker alkali, so it will produce OH minus in lesser amount. And in this particular case, it is not sufficient to neutralize and get the precipitate. So it's saying, and even in excess. So whenever we go for we observe such type of reaction, that yes, there is a no precipitation occurs even with the addition of, so we know that with NH4OH, so we know that this salt may be, this cation may be Ca+2. Now one thing, NaOH reaction, and so if we suppose, if we are going for lab for detection of these metallic ions, we are given some unknown substance. Now it depends on you, and it depends our quickness, that we can go for both the reagents. We can go for NaOH also, we can go for NH4OH. What, how it will be beneficial to us? It will help us, it will confirm us, yes, this is this particular, and because it is giving test for both the reagents, that is NaOH and NH4, and in both we will, again I am repeating, in both we will perform by drop, and then by adding in excess with NaOH and then NH4, drop by drop and then in excess, and we need to pre-cram this table. That is very, very important. So iron and in this part I would like to explain you one thing. See, iron plus NH4, okay, dirty green precipitate, it's Fe+2, and we get colorless in solution. Now we add in excess, we get dirty green precipitate insoluble. So this is the part which we need to cram, that it is in excess, it gives insoluble. Now what you can see, what we are doing here with Fe3, or we get a precipitate, or we can do it with anyone, we get a precipitate, so and along with we get a solution also. So in the beaker or in the flask we are getting both things, the precipitate and the solution, means this one and this one both. So when we add in excess or when we test in excess, so either we can go for two ways, either we take it as a whole without filtering it, listen to my words, we take it as a whole without filtering it, or we filter it and we proceed our test with the precipitate only. So both ways we can proceed, and we will observe what happens. Suppose here we are seeing that we have taken this FeOH whole thrice plus NH4Cl, right, and then here we have Fe2SO4 plus NH4 FeOH3 plus 3NH4 whole twice SO4. Now if you go for, so this way you have to run the reddish brown precipitate, this is giving this precipitate. Now what I was trying to explain you can observe in this one, because these are the simple ones. Copper 2 sulfate. Now here we have seen that copper sulfate plus NH4OH gives COH whole twice plus blue precipitate plus this one. So this is a combined, and this you can do this in this also, there is no problem in it. With excess of NH4OH, precipitate dissolves. So see, here we are taking COH whole twice plus NH4 plus NH4OH. So this is in excess, and we are taking this complete solution, means the precipitate along with this one. So we are getting soluble in excess of NH4 and form D2 solution. Now if we suppose, if you filter it and you go only with the precipitate, see the point. So here we have taken only the precipitate, and here we have taken in excess of NH4OH. So tetramine copper hydroxide we are getting, and it is also D2 solution. That's why I said that this is the characteristic property of. So this you have to learn. Now the point was that either you take the whole solution or you filter it and you proceed your reaction with precipitate. So this was what I was trying to explain you, and this again it's your part, you have to cram it everything, and then only it will be helpful, and it's scoring also, and it will be helpful in 10th class in lab, in 11th class and in 12th class. So this is the basic introductory for your lab for detection of ions. Now we will go for action of alkali on certain metals. So now let us take the example of action of alkalis on certain metals. So we are going to study the action of alkali on certain metals and what will the characteristic reaction, that when hot and concentrated alkali will be reacted with some metals, so it gives a soluble solution, soluble salt, plus there will be liberation of hydrogen gas. So this is the characteristic reaction. So by this hydrogen gas you will be able to know that it is giving some, what reaction it is basically given with this, is giving with this reagent, and you will get a colorless salt solution. So by this also you can identify some metals, unknown metals. Suppose you are being provided with some unknown metals or some unknown substance, so you will identify that which metal is, as you must have studied through flame, through the color of the flame, you were identifying certain metals. Now here you can identify with this reagent, with the help of a reagent, same thing. And you must have studied in the preparation of hydrogen gas some reactions. So we are having with all the reactions, and dear students, the reactions are to be crammed by you at this level. We have zinc, then we have aluminium, then we have lead. So all we are getting zincate, metaluminate, plumbite, and these are colorless ones, and they are liberating hydrogen gas. So there is nothing to explain you about. I was just going for the overview, and this is all about this action of alkali on certain metals. Now one topic is left. I'm going to take that also to finish this chapter, that is action of alkali on oxides and hydroxides, certain oxides and hydroxides, and basically the amphoteric ones, the aluminium, like that. So let us see it. So now the last topic we are going to touch it, and we will deal with action of alkali on certain metal oxides and hydroxides, and basically the amphoteric ones. Now before going to the amphoteric ones, let us recall that acidic oxide and basic oxide. So if you remember, and if an oxide reacts with water to give acid, it is an acidic oxide, and if an oxide reacts with water to give a base, it is basic oxide. Now apart from this, most of the metals, all the metals, generally most of the metals, they form basic oxides. So when they are basic oxide, they will react with salt to give, when they are basic oxides, listen properly, when they are basic oxides, they will react with acids to give salt and water, but they will not react with base. That is point clear. But certain metals which are amphoteric in nature, whose oxides are amphoteric in nature, they react with acid as well as base to give respective salt and water. So that's what we are going to deal with. So this is the characteristic, again it can be called as the characteristic reaction of those particular metals and their respective oxides and hydroxide. So if we take about, in that we have zinc, we have aluminium and so on. So zinc oxide, so basically zinc is a metal, so it should not react with acid now, but being amphoteric in nature, see, being a basic oxide, it is here reacting with acid. So here it is acting as a base, and it is giving salt plus water. Hydroxide, it is reacting with acid. So here it is acting as a base. So that is a comparison why it is acting as a base, because see, it is reacting with acid to give salt and water as the base does naturally. Now we have zinc oxide. Here in this zinc oxide is reacting with an alkali. So how it is behaving? So this zinc oxide is behaving as an acid. Acid reacts with base to give salt plus water. Base, it is acting as a to give salt and water. So these are the amphoteric ones. And my dear students, so this is the main thing, the characteristic reaction of some of the metals which are amphoteric in nature, the oxides and hydroxide, that they both react with acid and base to give and salt water. Although we know that metal form basic oxide, so they should not react with base. Again I am revising it, okay. But in the case of amphoteric ones, they react with acid and base to give salt and water. So by this way we can identify कि this is giving this reaction, it is reacting with both acid and base to give salt and water, so it should be the amphoteric one, so it should be that metal cation. And in the last, this KOH also goes for the similar reaction, as we have the reagent here. In case of amphoteric oxides and hydroxide, we can take potassium hydroxide as a reagent also, and it will also behave chemically in the same manner. So this is all about this chapter. We have completed this chapter, and in this chapter you must have seen that 80% part, 80% contribution should be from your side, because it needs a lot of cramming only. So I hope you will do that. And only one lecture is left. I think after 30th we will get some break. So summer break, so utilize it for your studies. And I will be discussing some on Saturday, means tomorrow. I will discuss some project also. If you and I'm not going to start mole concept, because I want to start mole concept as a fresh, because it's a very, I may say, it's a very challenging topic and a good topic, and it's a conceptual topic. Those who will understand the concept, numericals will be very, very easy for them, and those who will not understand, numerical will be very, very tough for them, even in 10th class, 11th class, 10th class, and so on. So I want to start it fresh. So that's all for today, dear students. Thank you very much.